Okay, so welcome to the lecture 48 in this course Classical Mechanics 1, and this is a tutorial class, and we will solve problems related to canonical transformation. And in the last class, I mentioned that 3 problems. So let us start with those 3 problems. First is show that the canonical 2 consecutive canonical transformation is also again a canonical transformation. Okay, so let us solution 1. So suppose you have a transformation QP to Q prime P prime is canonical. Then you find Q prime to P prime to another set of new variable Q double prime P double prime is canonical, again nickel. Then in this problem we have to show, this is given, so this is given, we have to show that transformation from QP directly to Q double prime P double prime is canonical. This is a straightforward problem. I use the method of exact differentiation. So given is that QP going to Q prime P prime is canonical. It can be the more variables, you can, if you want I, so for more variables no problem. Okay. So let us consider is canonical implies the sum over I differentiation Pi dqi minus Pi dqi sum over all I is an exact differentiation. Okay. So this is equation 1. Similarly, transformation from Q prime P prime I. So let us put many variables to Q double prime I P double prime I, okay, is also canonical given in the problem. So it also satisfy the Pi prime dqi prime minus capital Pi prime dqi prime capital is also exact, and let us, this exact is right d of f1, and this case it is also exact differentiation, so write d of f2, another equation. So I write with the denoted that with equation 2. Now let us consider this quantity sum over I qi dpi minus qi double prime, no, just a moment, qi, no, this we should consider sum of I Pi dqi minus Pi, capital P is in this case is actually in our case Q double prime, so Pi double prime d qi double prime. Also the similar correction one has to make here, it was not this let me correct this. So Qi Pi in the, look at this. So let me explain. Qi Pi is canonical. So Pi Qi minus Pi prime dQi prime will be exact differentiation. Similarly, Qi prime Qi, so Pi dQi prime to Pi double prime dQi double prime is also exact differentiation. Okay. So this correction you should make. Now we are looking for this, whether this term is exact differentiation, then we can consider that directly from Qi Pi to Qi double prime Pi double prime will be canonical. So this we can write sum over I Pi dQi minus Pi prime dQi prime plus Pi prime dQi prime minus Pi double prime and dQi double prime. So we have add and subtracted this quantity, and now you can see by using equation 1 and 2, this is your dF1 and this part, and this part is your dF2. So this will be d of F1 plus F2, which is say d of F3. Okay. So I can say that the two consecutive canonical transformation is a canonical transformation again. So the result of two consecutive transformation is again a canonical transformation. Okay. Okay. So now let us consider to the next problem, problem 2. Problem 2 was that find the values of alpha and beta for which this is a canonical transformation. Okay. So this for this we will use the Poisson bracket method. So Poisson bracket, so let me write Q is Q alpha cos beta p, and P is your Q alpha sin beta p. So let us consider the Poisson bracket between capital Q and capital P, and that transformation has to be canonical, means the Poisson bracket has to be 1. So the canonical this Poisson bracket between this should be 1 if the transformation, if the is canonical. Okay. So now let us calculate this Poisson bracket. So this Poisson bracket is del Q plus del P minus del Q del P del capital P small q, and this if we calculate, you will find del Q. So it is alpha Q to the power alpha minus 1, and del P will be sin beta. So it will be beta cos beta p, and the minus second term del Q del P will be Q to the power alpha beta minus minus plus, then sin beta p, and then del P del Q will be alpha times Q to the power there will be one more Q to the power alpha. So Q alpha Q to the power alpha. Okay. So these two terms if you combine, you have a alpha beta and Q to the power there is sin square, because remaining there will be cos square also, please make this correction, times alpha beta Q to the power 2 alpha minus 1, then sin square beta plus cos square beta. So p. Okay. So, you can find easily that this is alpha beta q to the power 2 alpha minus 1. Okay. So, now this quantity has to be 1. So, it cannot depend on q. So, 2 alpha minus 1 has to be 0. So, alpha equal to half, and if alpha equal to half, then it is q independent, but remaining with alpha beta. So, beta has to be alpha beta has to be 1. So, beta has to be 2. So, the condition that alpha has to be half and beta has to be 2 is the condition transformation will be canonical. Okay. Okay. Now, there is a simple simple question, and in similar fashion you can deal with many other problems. So, that now I have solved sufficiently many problems. So, you can solve the problems yourself. Now, the third problem, that this transformation, for this transformation you have to find a generating functional. So, we are trying to cover all type of problems such that you will be able to solve later. Okay. So, let me write again. So, this solution 3, this was q equal to q square, capital Q equal to capital P equal to P by 2 q. So, find a generating function. So, you have to remember that the various type of generating functional and the equation to solve this problem. For example, f1 was q, right. I am assuming no time dependence. f2 was qp, and similarly. So, let us try. So, you have to try which one will be suitable. So, in this case we find f2 will be suitable. So, f2 equation del f2 del q is p, and del f2 del capital P is capital Q. Okay. So, if I use this second equation del f2, it is very straightforward, is q, and q is nothing but your q square. And now remember, q and capital P are independent variable. So, this can be very easily integrated, that q square dp plus constant, this can be q square can be taken outside. So, this you have to be careful that which pair of variables are independent. For example, if you are trying to find f2, then this small q capital P are independent. So, they can q square, small q square can be outside. So, this will be q square P. Okay. So, one generating functional for this will be q square P, and you can check whether this is correctly producing the canonical transformation. For example, del f2 del q will be 2qp. Okay. Now, this is supposed to be p, small p. So, small p, this small p is equal to 2qp. Okay. So, this is your small p. Okay. So, this produce the correct transformation. Okay. We will consider more problems for finding the generating functional. Okay. So, let us consider problem 4. Problem 4. So, the transformation given like this, capital P equal to 2 plus 1 over root q cos P bracket root q sin P, and capital Q equal to log 1 plus root q cos P. Okay. Now question is find the generating functional f3, and you remember f3 is function of capital P and Q, right. So in this question it specifically asked you to find f3, so you don't have any choice, or you don't have to look for that which generating functional will be you'll calculate. So for that solution, now to find a solution, you have to write the equation of motion for this generating functional. It is function of P. So f3, both equation has negative sign, so this is Q, and del f3 del Q will be minus P. Okay. So this we can, but the transformation apparently looks very complicated. So in this case you have to simplify the canonical transformation. For example, if we simplify this, e to the power q will be 1 plus root q cos P. We have to use these two equation carefully. So that means this equation can further, because we will be using f3 is P, yeah. So we will be using the q from this equation from here. Okay. So q cos square P, if I equal to e to the power q minus 1 whole square. Okay. So q, this implies q equal to e to the power q minus 1 whole square by cos square P, and you remember P and Q are independent. So this whole factor in the numerator can be taken out of the integration. So now I use this. So del f3 del P will be minus e to the power q minus 1 whole square by cos square P. I just substitute q in this above equation. So f3 will be then just a integration e to the power q minus 1 whole square by cos square P dP. Okay. But it is f3, and for f3 small p and capital Q are independent. So this you can write minus eq minus 1 whole square outside, and then cos square P, that means sec square P dP integration, right. And that is tan P, cos square P integration. So this will be e to the power q minus 1 whole square tan P. Okay. So this is this is the generating functional. Now I leave it exercise for you that this generating functional, please check, will produce the canonical transformations given above. Okay. Okay. So, and also try to find, if possible, other forms of generating functionals. Okay. So, next problem we will consider, few more problems we will consider. So, next problem, problem 5. Problem 5, transformation, again regarding generating functional, because finding generating functional is the difficult one for the student. So, I am spending more time or considering more example on finding generating functional. P equal to half, this is the problem, let me write P square Q square, and Q equal to small p tan q, right. Find generating functionals for this transformation. For any transformation you need to find generating functional. My suggestion is that first you check whether this transformation is canonical or not. So, please verify that this is a canonical transformation. Okay. So, let us try to find the generating functional. So, maybe we can try F1 and one more. So, if we try F1 generating functional solution. So, let me write solution. F1 is Q Q. So, del F1 del Q is P, and del F1 del Q is minus P. Okay. So, we have to simplify the above canonical transformation to find small p or capital P, and we find, then we will substitute, and then we will integrate. Okay. Okay. So, if you try to find the capital P, for example, if you want to use this to try to find capital P. So, capital P is half P square plus Q square. Okay. Okay. I will write in the okay, Q square. So, this can be written Q square by 2 1 plus P square by Q square. Okay. So, now Q by P is tan Q, capital Q. So, this we write Q square by 2 1 plus Q by P is tan. So, it is 1 over tan square Q. Okay. See, we are looking for F1. So, we should write our final expression, that means for capital P or small p, in terms of small q and capital Q, such that when we perform integration, this small q and capital Q are independent variable for F1. So, we can take one variable outside the integration. So, this is Q square by 2, then 1 plus tan square Q by tan square Q, and if we simplify this, you will get getting q square by 2, and then it will be cosec q, right, 1 sec and this tan, so it will be cosec q, because 1 plus tan square means sin square x by cos square x divided by sin square x by cos square x. So, cos square x get cancelled, then 1 over sin square x. So, this will be okay. So, now capital now capital P will substitute in the F1 equation. So, del F1 del Q is minus P. So, we will have this equal to minus q square by 2 integration cosec square q dq. So, F1 implies F1 is this. Okay. Okay. So, this F1 can calculate. So, F1 equal to cosec q integration, if you perform, then it is plus cot q. So, half q square cot q. Okay. So, this will be plus some constant, and you can check that this will generate the transformation. Okay. Now, if we wanted to calculate F3, suppose another generating functional F3. So, F3 first you have to know is function of P and Q, right, and equation of motion del F3 del Q is minus P and del F3 del P is minus Q. So, again this P we have already calculated, but now remember P and Q are independent. So, I should take here the P square common. Okay. So, P I will consider half P square by 1 plus Q square by P square. Okay. Because P square is independent with P is independent with capital Q, and now Q square by P square, if I substitute Q by P is tan. So, this will be, so half P square plus 1 plus tan square Q. Okay. So, 1 plus tan square Q is basically your 1 plus tan square is sec square. So, half P square sec square Q. Okay. So, now your F3 will be, F3 is minus P square by 2 integration sec square Q dq. Okay. And if you perform this integration, it will get a tan Q. So, F3 will be minus P square by 2 tan Q. So, this will be the generating functional for this. Okay. So, this is lack of time, we will not consider any other problem for this class, and this will conclude your lectures on canonical transformation. In next lecture, we will consider a new topic, that two body central force problem. So, bye for now, and we will shortly in the next lecture we will start with the two body central force problem. Bye.